just closed up the other slides, so these are still open. There we go. Okay, so that's more like a symmetric one. Now, the book does mention what outliers are. It doesn't really go into them. So again, to make this, how do I say this? Really, I'm just going to stick mostly with the book here. So I'm not going to go really beyond what they do with outliers. But basically, an outlier is a value, as it says here, extreme, meaning it's really small when compared to the other values, or it's really big when compared to the other values. If you imagine on the, well, I'll get to that in a second, but that's really what they mean by an outlier. It's an extreme data value, so it's far away from the rest of the data values, so to say. That's also helps explain, well, that's another example as to why, a visualization is really good. I mean, if you were to look at a frequency table, it may not be so easy to see, or even all the data listed, it may not be easy to see what the outlier is, if there is one. However, with a histogram, it's a lot easier to see if there's an outlier, or more than one possibly. For instance, here's an example. I mean, if this example was not here, we just had this graph, we just had this data. Although here, I guess this example is not bad. There's not much data here, and hopefully you can see that 1 is much smaller than all the other data values. So 1 you can see is an outlier. We also see that from the graph. But can you imagine if we had, let's say, 1,000 data values, or even more than that? Then it might be hard to see what the outlier is if there is one. You might miss it. That's why graphs are so important. Kind of like the old saying, I guess, a picture is worth 1,000 words. So, but hopefully you can see that 1, whatever's in here, is an outlier here. That is, kind of far away from the rest of the data values, as you can see. That's pretty far away, so that's an outlier. Okay, so that is an example of an outlier. It's kind of like it's far away from the other values. Okay, so that's good. So again, that's just, what a distribution is. Basically, again, you're looking at the values a variable can have and their frequencies. And again, as I said, generally to understand that, we like to use frequency tables and histograms to analyze, to consider distributions. Right. Now, here what I said already is, here what I said as before, measures of central tendency. Again, some people might say, well, this is the center of the histogram, right? Like over here when I said, oh, the center, it looks like it's over here. We have to think mathematically. That's not really precise. Why is this the center? What makes it the center, right? We have to be precise about this. What exactly is the center? Well, there's different ways of thinking about it, as this is showing you. One way to think about the center is the mean. The mean is just an average. That's what the mean is. It's just an average. In other words, you add up the number of data, you add up the data values together. Remember, we're working with quantitative data, right? Because we can add, subtract, and do all that stuff. So we add up the data values and we divide by the number of them. It's just an average, like in the typical sense, so to say. I mean, here's an example I did, right? Here's our data from whatever. We're adding them up to get the mean. And we're dividing by the number of data values, which is here. And doing that, we get this. That's what the mean is. So again, that's one way of thinking about the center. The mean. The mean, again, is just like an average. Now, it's good to have examples, of course, so here are some other examples. So this one I just said, okay, let's suppose the price of peanut butter at 5 different stores was this. So I guess I went to 5 different stores in Oneonta or wherever. I recorded the price of peanut butter. By peanut butter, I don't know. I just did it for fun. And what happened here was I recorded the prices. Recorded the recording. I thought it wasn't recording. That's why I stopped for a second. So I recorded the prices. This is quantitative data, right? I know it's, the price is something, but these are numbers. They represent amount. How much the product, how much the whatever it is, the product is. So we can do calculations with these. Let's find the mean price. Just like before, you add them up, divide by the number of items. Here there are 5. We add up the 5 prices and divide. Get this. So the mean price here was $3.58. I would tell you how many decimal places to round. Since it's money, it represents, currency. I rounded to 2 decimal places. I mean, originally when I did this is actually what I got, but I rounded, so. Okay. Now we can also have a frequency table, as we saw before, frequency tables. How would you get the mean here? Well, it is tempting to write out all the data, to list 12 4 times, to list 14 once, 7 5 times, and 5 6 times. But we don't have to do that. And in fact, I wouldn't do that. You're just really, in a sense, going to waste time by doing that. What can we do? Well, if 12 is listed 4 times, if you were to add those 12s together, right, you would get 12 times 4, which is 40, which is actually 48. 14 is listed 1, so we would just do 14 alone, which is 14 times 1. 7, there's 5 of them. So if we were to add those 7s up together, that's the same thing as 7 times 5, which is 35. That's just multiplication. Five added to itself 6 times is 5 times 6. Remember, you can add in any order you want. That's one of the nice properties about addition. So when we do that, so in other words, instead of having to list the data values, right, one at a time, so instead of having to list 12 4 times and 7 5 times and so on, we can just multiply the data value by its frequency. So we have 12 times 4 plus 14 times 1 plus 7 times 5 plus 5 times 6. And then how many data values are there? Well, that's from the frequency, right? We just add the frequencies together. Right? If you add the frequency, that's how many data values there are. Doing so, we get 4 plus 1 plus 5 plus 6. So we get 127 over 16. Like the 127, that's the sum of the data values. 16 is the total number of data values. And this is our mean. Okay, so that's an example. Are there any questions about that? Well, here's another one. It's the same idea. Right? In this one, you probably could get away with listing all the data values. There's really not that many. But look at this one. Would you want to list 20 25 times? I wouldn't. What about 19? Would you want to list that 40 times? I mean, probably not. But again, what's nice is you don't have to. Right? Just like I was saying before, instead of listing all the numbers and simply adding, you can just multiply. So to get the mean, we have 20 times 25 plus 16 times 30, plus 18 times 35, 19 times 40, right? That's the sum of the data values. And then, to get the total number of data values, what do? You add the frequencies. That's what I'm doing here. And so you do this calculation. The top is equal to the sum, which is 2,370. There's 130 data values, right? That's adding the frequency. So this quotient is the mean, which is 18.23. So that's the mean. Now here's an example I want everyone to try. Find the mean of this data, the mean of these average scores. So let me just stop the recording, and then I'll give you about 3 minutes.